As with all the other lessons, I keep telling you we're only adding one small little detail to the lessons that we've already learned. And in Lesson 10.4, the only thing we're changing is the fact that we're going to deal with inequalities instead of equalities. Solving inequalities is the exact same as solving equalities. You still want to get the variable alone on one side and your constant numbers on the other. Now, the only difference between an equality and an inequality is simply the sign. An equality has an equal sign. An inequality, whoops, I used the wrong thing here. There we go. An inequality, instead of using an equal sign, uses a greater than or less than sign. So that's what I mean by an inequality. So you're not ever going to magically change the inequality sign from a greater than or less than. You're never going to flip the sign over except if you multiply or divide by a negative number. So when I'm solving these down here, when I'm talking about this right here, this sign is never going to change unless when I'm solving for the variable, if I multiply or divide by a negative number. Then I'm going to flip my inequality sign over. So let's look at an example here. I need to get rid of this 1 off of this side, so I subtract 1. If I subtract 1 from this side, then I subtract 1 from this side. Now, yes, I did subtract. I put a negative number in there, but I didn't multiply or divide. I just subtracted. So now I'm left with 4x is greater than 12. And now to solve for this x, I divide both sides by 4. Now the question is, am I multiplying or dividing by a negative number when I do that? And of course the answer is no. So after I divide both sides by 4, I'm left with x is greater than 3. So then to plot this on a number line, I need to go to 3, and all of my x's are greater than 3. So it's hard to do on the computer, so I want you to take your pencil and I want you to make a dark line all the way here and then draw you an arrow to indicate on the number line that all of my solutions are greater than 3. Now, the question is do you need to put an open dot or a closed dot? Is x equal to 3? No. So therefore this needs to be an open dot right here. Alright, for our next example, you can do this one of two ways. I like getting all of my x's over on this side and all of my numbers on this side. However, I'm like most of you and I don't want to end up doing more steps than I have to. So for the sake of convenience, all of my x's are over here, and let's just go ahead and put all of our numbers over here. So I need to subtract 8 from both sides to get rid of this. Subtract 8 here, subtract 8 here, and that leaves me with negative 15 is less than 3x. So now to solve for x, I need to get that 3 unstuck. So I need to divide both sides by 3. So am I multiplying or dividing by a negative number? No. So my sign stays exactly the same. So it would read negative 5 is less than x. Or if you want to flip it around, if you're a staunch person that wants to get the x on the left-hand side, I can flip it around and say that x is greater than negative 5. It's saying the same thing. Look right here. X is greater than negative 5, or negative 5 is less than x. These are both saying the same thing. So now to graph that, x is greater than negative 5. So here's my negative 5. I want everything greater than. And again, it's an open dot because x is not equal to negative 5. Tune in to part 2 for the rest of the examples.